Here's another relative velocity problem. A boat moves east at 5.2 meters per second relative to a river that is 85 meters wide. All right, so let's see what we can do here. The velocity of the boat relative to the river is 5.2 meters per second east. The river flows south at 3.8 meters per second. So the velocity of the river relative to the earth is 3.8 meters per second, and it flows south. Here's our river, and the river is flowing south. It says that the river is 85 meters wide. From there to there is 85 meters. So we need to find a couple of things here. We want to find the velocity of the boat relative to the shore. Velocity of the boat relative to the shore. Well, the shore is the earth, isn't it? So how would we do that? In terms of variables, we'd go velocity of, we have to put the B first, the boat first. I'll underline those so that we know that those have to go together. And the only thing that we're given is BR. So we're going to have to go with that. And then we're going to add to that, even without thinking, we know that that has to be an R because birds of a feather flock together. And what does this give us? Look at that. So there is no need to flip any vectors going the opposite way. This will give us what we want. Part one, let's find the velocity of the boat relative to the shore. 5.2 meters per second east, 3.8 meters per second south. So let's sketch those vectors out. East would be that way, 5.2 meters per second. South would be that way. This is only 3.8, so I'm drawing it a little bit shorter. And so the velocity of the boat relative to the earth is going to be that vector right there. And once again, we're going to need an angle right there. Using the Pythagorean theorem, we're going to get 6.4 meters per second. And then we need an angle. From the picture, we can see that this angle should be less than 45 degrees. If we get an answer bigger than 45, then we need to look back and think, something might be wrong. When I did this, I got 36 degrees. 36 degrees what? 36 degrees to the south of east. East is this way. This is 36 degrees to the south of that. South of east. So that's the first part of this problem. The second part says we want the time required for the boat to cross the river. So in case you're writing this down, I hope you had enough time to write down that 6.4 meters per second answer. Let's scooch back up here. And at the top of the screen now, we need the time required for the boat to cross the river. The distance is 85 meters. And the velocity south, this is not, there's not a southward component of this 85 meters. It's only the easterly bit. So for part two here, we're going to say, well, the distance is equal to the velocity times the time. The distance in the east-west direction is the boat's velocity in the east-west direction multiplied by the time. And when we type this into our calculator, just in case we need this number later, it's helpful to record a few extra significant figures. I got 16.35, but when we report our answer, we want to use proper significant figures. So when we report our answer, we should say 16. But as we'll see here in just a second, if we need to use this time later on, we should probably use the 16.35. And that's what we're going to do, because question 3 says how far downstream the boat will have drifted. So now we're talking displacement in the southward direction. So that's going to be the velocity in the southward direction. I'll just put little arrows to indicate south, multiplied by the time. So this one up here, let's go back for a second. The displacement in the easterly direction is equal to the velocity in the easterly direction multiplied by the time. Well, this time applies to both. So the distance that we will have drifted is going to be the velocity in the southward direction, which is 3.8, meters per second. And now we're going to multiply by the time. And just so that we don't round too soon, I'm going to use that earlier version of time, 16.35. And when I type that in to two significant figures, I got 62 meters.